Elon has done something special here with the local grid operator to make that process go as quickly as it has.
Texas is super primed to vastly benefit from where we're going in the next 5 years. The most hilarious thing of this whole thing is that I remember people were freaking out so bad about EVs. Like, EVs are going to destroy the grid. What's funny about EVs is they're probably providing more like load balancing than anything, because people are plugging in and charging at night.
The electricity sector might be one of the most exciting sectors to be a part of right now.
Curious to see what y'all think, but my sense of how this is going to play out is that right now, with data centers becoming this huge just generator of demand for electricity, that we're going to have an entirely just booming sector of the energy economy that emerges around behind the meter stuff, and that will drive demand across all forms, natural gas, solar, batteries, as fast as small modular nuclear reactors can come online, demand for those as well. Like, there's going to be a whole bunch of, I guess, pull forward of demand for anyone who can meet energy generation supply today in any form, plus then a whole bunch of investment into those follow-on or future energy generation technologies. And that it's like, yes, we have this huge problem with how regulated the grid is, how slow moving the utilities are, but we're going to have like almost a tale of two cities, where there's all that stuff that's attached to the grid, and then there's everything else. Like, we're going to grow way faster than all of the expectations, or all of the projections that are based on the expectations of how fast the utilities can grow, because all that other stuff is just going to appear, and it's just going to be located, behind the meter, off grid, and supply things directly.
Yeah, I'm a big believer in that thesis.
So what gives you? So what are the variables you're looking at that makes you confident in that thesis?
Well, I mean, it's stuff I've been talking about for years. I mean, you got the increasing proportion of your overall delivered cost of electricity that is transmission and distribution costs, as opposed to the actual generation cost itself. So like, that is continuing to tick up. Meanwhile, like, a lot of generation costs are coming down, or at least are staying flat. So like the cost itself is very significant. And as that continues to rise, that will just make behind the meter, distributed generation look more attractive on a relative basis. Then compounding
Matt. Sorry, just to kind of, for like my stupid brain. So the cost of moving the electricity is going up, while generating the electricity is flat or going down. So if you can, where you're creating the energy and electricity, the costs are great, but when you're trying to get it to the end point, that has been the issue. It's making it difficult for companies or businesses or whatever, or the civilization, to take advantage of lower energy costs. I just want to make sure I fully understand that point.
Yeah.
Okay.
Yeah.
All right.
And that's basically because to get it from where it is to where it needs to go, you have to go through the grid, and the grid, A, is old infrastructure, and B, it's heavily regulated. So like, changing the system as it exists is difficult. Like, and it's basically, the amount of laws that stand in between you and getting what you want done in the time frame that you want it done.
Yeah. State, local, federal laws, environmental laws, like these all get in the way. And then you've got the interconnect process, which is just dragging things out. And then you got like, increasing lead times for critical equipment like transformers. So basically, connecting to the grid which used to be like a 2-year process, is now like a 5 to 7 year process. And so I think we're just in this situation where you've got the like economics of kind of doing on-site generation are, probably as good as they've ever been, and are like at least close to comparable to grid supplied energy. And then on top of that, you like are eliminating a huge amount of the timeline and regulatory hurdles if you can do it on site yourself. So I think those two things are going to lead to the trends that Hans was talking about coming to fruition.
So how much time does it save then if you build an off-grid system?
As quick as you can get it up. I mean,
Okay.
like, there are some where you can get it up in like, 6 to 9 months, maybe.
Mhm.
I think that's aggressive, but I've heard rumors that that's at least possible. But I think even there, you're running into issues like GE Vernova is basically sold out of gas turbines until 2028. You really can't do behind the meter solar and wind because that's not like base load power. I mean, part of the reason nobody wants to do this is because nobody wants to like be in charge of managing their own power supply. Like if you're just some steel company, you don't want to like manage a power plant on top of running a steel mill, right? Like you want to do the thing that you're really good at and like outsource the rest. But I think just how frustrating this interconnect process has become and the timelines elongating for as long as they have it are just forcing the hands of some companies.
So as long as you own the land and you have your building permits, you're good to go, and it saves like 2 to 5 years of hassle.
Yeah, like depending on what you're doing, like you might still need an air permit. There could be some other regulations. But if you're going to island yourself from the grid, then yeah, you can completely eliminate all these headaches.
Okay.
And so this is this the literal process that Elon with XAI, is that the literal process they're doing where they have the land, they're bringing in generators, and they're just limited by how quickly they can get everything hooked up and going, and basically would they truck in the natural gas? Would that be through a pipe? Like how would that work, like logistically speaking?
Yeah, so like I know in XAI's particular situation with Colossus, like so they, Elon's mode is let's go fast, right? So they brought in some temporary generators. I believe they were natural gas, so there must have been a gas supply hookup that was available at that site, which I think was part of the reason that they chose it. But there was some existing interconnect amount that they then went and actually increased, working with Memphis, whatever the utility is there in Memphis. So they were essentially running these generators for several months just to get the data center up and running and to get these, grok essentially improving as fast as possible. But then they were working, with the local regulator to like speed run the interconnect process. And I honestly wish I knew more about how they did that, because from what I understand, they were able to get their interconnect and their like connection to the grid worked out extremely quickly, like I don't know, maybe 12 months or something like that, which is kind of unheard of.
Huge shout out to the sponsor of our podcast today, Rebellionaire. They are a brand of Halter Ferguson Financial, and they are a great company for helping with risk management, trimming and adding for Tesla long-term investors, even some help with covered calls. They are a longtime supporter of the Tesla community, and we appreciate their support of this podcast.
Yeah, these guys have been super familiar with the Tesla story specifically. They've been doing some unique research analysis of the company. They've done road trips on FSD, full self-driving with the cars. They've tracked the energy sector in a very close, innovative way. And we know a lot of you that watch this podcast and this channel are huge Tesla fans and also Tesla investors. Oftentimes when you talk to a financial advisor, usually you get the cold shoulder because it might be too risky. Whereas Rebellionaire actually embraces that type of thought process and that type of investment strategy and understand it deeply. And so if you're interested in checking them out, we have a link for them in the description and in the comment section below. You can go to rebellionaire.com/Farzad, rebellionaire.com/Farzad, and then they'll know we sent you. And now back to the podcast.
Yeah, Matt, is there a different process? Because they already had an interconnection between them and the grid, like you said. That factory was there. It It already existed and had quite a bit of power infrastructure that supplied it. So they took that, then they supplemented that with their temporary generators to where they could run, and obviously using megapacks as you said people don't really want to manage their own power plant. Well, that gets a lot easier if you've got, a giant installation of megapacks that manage your power plant for you. But yeah, so if they already had that existing interconnect, is there a faster process to modify an existing connection than, generating a new one like Greenfield?
Yeah, so it typically is going to be faster to increase your interconnect. So if you like, I forget what that site was, but let's say it was 30 megawatts that was already permitted, so they could draw that on day one. But they needed, I wish I knew what the exact size was, but let's say it was 100 megawatts total that they needed. So maybe they had 70 megawatts of these generators that were you could do 30 based on your interconnect from the grid. You're trying to increase that to 100 through the process, but you've got this kind of temporary solution with the on-site generators. My understanding is it's faster to go to just increase your interconnect amount, or like your I forget what it's called, but like the limit that you're allowed to import from the grid. It's faster to do that than to just start from nothing. But it's still, in my experience, I actually went through this process with one of a plant that I was, my company was trying to go from 60 megawatts to 225. And so we went through the whole interconnect process there. And this was like 5 years ago, and it still took probably 3 years, I want to say, and like millions of dollars to go through that interconnect process. So Elon has done something special here with the local grid operator to make that process go as quickly as it has.
I prompted Grok on this Memphis project. It was 122 days
That's insane.
from announcement to operation. 122 days, and one of
but that's not going to be the same timeline. That was from when they started the installation to when the data centers were, or like the GPUs were up and running and training, but that was on the temporary generators. They literally just got the utility company just completed building the new substation where they transferred over from using those gas turbine temporary generators to now drawing power directly from the grid at whatever that new rate is. And that the utility is also building the new substation that's going to supply Colossus too. And I don't know how long has Colossus been up now. It's been 6 or 8 months. So I'm sure that they applied for all those permits to get that substation connected, when they broke ground or even before that. And so it's been, I think to Matt's point, at least a year, maybe longer, between when they planned the project and when they actually got the power from the utility company, instead of having to, do this temporary in between solution. So Matt, based on your understanding, if when you went through that process, if you had the ability to just have an unlimited, quasi unlimited amount of battery storage, to where you could promise your power provider that, hey, we're only going to pull power from you off peak, so that we're not having any sort of impact on your ability to meet peak power demands, do you think that would have sped up the process?
Well, I don't think so in this particular case. So we were a generator. We were not like an electric load. So that's a slightly different situation. But my experience going through this was that they really only care about what your maximum is, not like what your average is. So I think one of the things that XAI has done, which is really helpful and probably helped them speed this along, is they did have all this backup power on site, and then they've got those mega packs. So they can work at the interconnect kind of limit, and then for if they want to be kind of consistently operating over that, they can do that with a lot of in-house power, so that they're always kind of at that limit. Now, what was certainly not my experience, but if you've got a more forward-looking regulator, what I think would make some sense is, okay, you're permitted to do this amount of electricity on your grid. Your load's normally going to be up here. Based on our study of the local infrastructure, we think you're mostly going to be okay. But if there's some emergency, or if we're seeing some issue on the grid, we're going to dial you down, and you need to respond immediately. And because they've got the mega packs, and it even more so if you have some flexibility on your workloads, meaning if you can dial down the electric demand from your GPUs, then you're willing to work with the grid operator, and that provides a huge amount of value to the grid actually. And then you can go from, this experience when I went through it, which was like, it was very rigid. Like, here's our number. You can operate to this number. You can operate, 100 kilowatts more than we say, but you can also operate 24/7 at this level. Like that was kind of the mindset of all the parties involved when I went through it. I think where the industry's gone in the last 5 years is, both the grid operators and the electricity users basically saying, we can be flexible, and maybe try to provide some value back to the grid. The batteries themselves can provide a lot of ancillary services, which helps us to stabilize the grid, even when we're not using those. So like, there's some benefit to the grid of having that. So I think if you're working collaboratively with your regulators, there's probably some better paths forward here than the way that, the system was originally designed to have these processes go.
Well, and just for the audience, what the challenge that these regulators and these utilities were facing is that, if you don't have the ability to store even one electron worth of electricity, you have to coordinate then this massive set of infrastructure that's across the whole country, potentially, where you're getting power from, this wind farm in, California, and you're sending it over here to Utah or whatever, or the other way around. So that, like, maybe that's supplying part of the power to all of these people that are using power, but no one is using power. It's not like power just usage is flat throughout the day. There are times of the day where it's higher, times of the day where it's lower. And so like, their margin for error is really difficult. And you can get into these really complicated dynamic situations where, a small power failure happens, there's a storm somewhere and it knocks out power here. And then that has a cascading ripple effect throughout the whole system that makes it really hard for you to do your job. And so they're having to plan anytime they bring in, a massive new user of electricity or a massive new supplier of electricity into this extremely complicated system. They're having to be able to understand the full impact that could have on the system in, a bazillion different scenarios before they say yes. But now if you come into that situation and you have the ability to have those batteries, regardless of whether you're a supplier or a user of electricity, then that ability to have some buffering in the system means that the job of the utility companies who are trying to coordinate moving all this electricity around to everywhere gets a lot easier. And so, yeah, that's where this, I think they have the ability, like the utilities have an ability to move faster than they used to, because the batteries give them the dynamic ability to respond to changing complex situations a lot better, a lot faster, and a lot easier.
So predictability and, like you said, giving some sort of buffer is like an extremely helpful tool for the utilities to work with you, right? So if you can give them something like, okay, there was a map that Jordan showed on the last time we had him on. There was a map of all the different natural gas pipelines that I think it was like, remember all those red lines, Jordan? Okay, so Matt, would you agree with the statement that the areas with the largest access to natural gas and the pipelines, like where you can actually get it from what the infrastructure that they have built up, are those the best places for the near to medium term for these AI companies to like start building their data centers? Is this like if you're thinking about, okay, I need to power my data center, nuclear is going to take forever. Solar has just become more expensive because we're basically blocking out China, but I got batteries and I got natural gas. So is that why XAI is in Memphis? Is because maybe they had a surplus of natural gas and they had a very good infrastructure around natural gas, and is that why they ended up there? Is that the thesis?
Well, so I think the Colossus site is a little bit unique in that, I mean, you had an existing interconnect agreement. I mean, your absolute best case scenario is where you've got like a an existing, let's say some manufacturing plant that, went bankrupt, but they've got a 50 megawatt interconnect agreement with a substation right there, and there's natural gas lines running close by. Like that's a gold mine. Like that's what every data center would love to see. So that you can connect immediately, and then the gas supply is nearby to allow for future expansions. That'd be the best case scenario, because the interconnect, I think, really is the gating item for a lot of these sites if they're not going to go completely off grid, which I think for the most part, they might consider doing that on a temporary basis, kind of like what we saw with Colossus. But generally speaking, I think most data centers are their main preference would be just to be connected to the grid, and have the power through there. I saw a study recently that was, and I might be getting these numbers mixed up a little bit, but there was a survey of data center operators and kind of decision makers, and it was something like 6 months ago they ran the same study, and only 10% of these decision makers were planning to use on-site power at their data centers, and just 6 months later it was 30%. So I think location to natural gas as something that is of interest when you're choosing a location. I think that probably wasn't a huge consideration before, but as more of these data centers are considering on-site power for the first time, I think you're going to see that increasingly become an option. There are some other options. I mean, geothermal is one that sounds really far off, but I think it's actually a lot closer than people think, and I certainly think it's a lot closer than SMRs. I think in general, my understanding is most of those won't be co-located either, but you do see a lot of, I think these hyperscalers are looking at all different options. I mean, Microsoft had a deal to do this. I forget what the company was, but there was a company that was operating a 1 gigawatt nuclear plant that Microsoft was basically going to take all the output. So I think you're going to see some creative solutions like that, which will probably face their own regulatory scrutiny. And I think this is going to be a type of scenario where, because this problem is so big and the demand is so large, there's going to be a lot of different strategies that are pursued.
Do you think
natural gas is the most obvious, I think?
Do you think at the moment they're just kind of picking the low-hanging fruit?
Yeah, like this one nuclear plant, like there's not a lot of like operable 1 gigawatt nuclear power plants that you could co-locate a data center on, just hanging around. So like there's some weird situations like that will help on the edges with some of these. But like even then, this has been in like legal battle for, I don't know, a year or something like that since it was first announced. So even the low hanging fruit comes with no shortage of hair on it. So this is just a hard problem.
Well, I'm just, like, where my interest lies is what happens when we've picked all this low-hanging fruit. Like, for instance, you get an interconnect and you throw battery packs on it, and you use the grid power at night, buffer it, etc. But getting past that, moving to these fully off-grid solutions, if you look at it from a blank slate, what is the best and most efficient way to do that? And one thing that interests me that I forgot about that Jesse brought up on Twitter the other day was, do we actually need all these transformers? For example, all this compute uses DC power, as I understand it. And so what you do is you take the generation AC and you convert it to DC. But if you already have solar panels and batteries generating electricity, couldn't you just you could remove a lot of that transformer architecture and that burden by just keeping it DC end to end and saving a lot of the power, because there's inefficiencies whenever you convert that power.
Yeah. I mean, there definitely are. That was something I remember Elon had a post about that, like maybe 3 or 4 years ago, something about like maybe AC was a mistake after all.
So, and real quick, Matt, so can you give the audience and myself a reason why do we have transformers today? Why don't we have just DC to DC today? Just so we're all on the same page.
Yeah, so all the appliances in your house, pretty much everything on the grid runs on alternating current. It also is great for transporting across long distances. So one of the problem with the early transmission lines is, like, if you were trying to transmit over long distances with DC power, you'd have very high losses. With AC, if you step it up to very high voltages, you have very low losses. So you can be transporting, at 136,000 volts, 136 kilovolts, I guess it is. Yeah, so 136,000 volts across hundreds of miles, and you might have like a 0.5% line loss, somewhere in that neighborhood. So,
which is literally 1,000 times the voltage that's coming out of your outlets in your house. Just to
so like that's great for minimizing losses over long distances, but then you can't use that power at those voltage levels. You'll fry all your electronics. So the transformers step down the voltage to something more usable. So that the whole grid was basically built out to have this kind of, you have these large centralized power plants. They'll step up their voltage on the grid so that it can, transfer over long distances without a lot of losses. And then when it gets to where it needs to be used, it'll get stepped down. So you'll see these, like if you ever see a substation in your neighborhood, you might be stepping down from 136,000 kilovolts to, it's been so long I don't remember, but maybe a few hundred, kilovolts or something. No, not kilovolts. Forget my
distribution
numbers,
usually happens at 600 volts, or like local distribution happens at 600 volts typically. And so then, when it gets to your, they'll get it into your neighborhood on a 600 volt system, and then it'll hit more transformers. That, if you've got overhead power in your neighborhood, then it'll be up on the poles. If it's underground, then that's what those green boxes are. And there's a transformer in there that changes it from the 600 volts that they're moving it around after the substation into the 115 volts that you have in your house, or 240, whatever. However you bring it in.
No, that's exactly right. So we basically built this entire power infrastructure around this methodology, but solar panels generate in DC, for example. And so then you've got an inverter that basically takes that DC power. You lose a decent amount of the power output converting it from DC to AC. And then, you have to step it up onto the grid. And then you're basically stepping it back down to use it at the data center. It's like, well, if you could just do it all DC, store it in the battery DC, and then use it at the data center DC, that'd be the best case scenario. I think the reason I'm skeptical of this as a near-term solution is nobody wants to, you basically can't site solar with a large data center. I mean, you would need to have hundreds of acres probably, and then massive amounts of battery storage. And then you're significantly overbuilding how much solar you would need in order to have that, to turn solar, which is, intermittent and follows that, that generation curve that basically just looks like a bell curve. You'll take that profile and you want to flatten it to get to something you can use all the time. Well, you need so many batteries, and the costs associated with that are so significant. And then the amount of land that you would need to use, that's just not a solution that is, I think, really viable at scale right now. So it kind of sounds cool on an engineering front, and it wouldn't surprise me if in the long term we do get some of that type of scenario. But I think the benefits of saving a few percentage on your inverter losses compared to how much overbuild you'd need to do, and the headache of managing such a large site. I think those kind of overwhelm the benefits of just using AC power.
What if you had just a splash of natural gas generation? Hans is thinking the same thing I am, because this is what the people.
So Jordan, explain to the audience, you have, your house is powered by solar, right? But you also have some backup gas generator.
Oh.
So why did you do that? Explain that so that people can understand what you're talking about.
Okay, so there is an option. I haven't done it, but I do have this option with the system that I build at my house, where I can plug in a generator into the inverter. So I have basically my solar power coming in, and I back that up with batteries. Now in wintertime, I might get down to 2 kilowatt hours per day that's actually generating. Whereas here in the middle of the summertime, I'm getting 45 kilowatt hours. Well, how do you bridge that gap in between those two? What I could do with my system, for example, is just get a small natural gas generator, any type of gas generator, and just run that constantly at 500 watts or 1 kilowatt for 24 hours. And that gets you 12 to 24 kilowatt hours throughout the day. So it's, and what that does is it'll store it in the batteries when it's not needed and then discharge it when it's needed. So just that little bit of power, which is like maybe 10% of the total generation capacity that I have, will fill in all those gaps, or could fill in through all those gaps throughout the year. And people who have modeled these off-grid solutions, that's what they're looking at. It's, once you get above 90% batteries and solar, it gets really difficult and really uneconomic. So if you just use a little bit of natural gas, 5 to 10%, it may be able to do it. You would still have some conversion losses there, but because you'd be inverting the AC power from the generator to DC, but most of the system would still be DC. You'd get rid of all those distribution needs and most of the transformers.
And this solves that problem that Matt was talking about, where he said you would have to overbuild your solar. That's what he was talking about, that you have to to go, if you're supplying, because to Jordan's point, like there's, if you're in the middle of winter and then you have a storm and you have like 2 or 3 days where you get basically no sun, well, then how do you run on solar? And so to go from producing and using like 95% of your energy that you consume at home through solar and batteries to 100%, you might literally have to build 2 times or 3 times as much, 4 times, as much generation capacity, or like solar. And so like you make your system way, way more expensive in order to just make it that last couple of percent. Whereas if you just say, hey, that last 5%, we're okay just using a cheaper natural gas solution, then you can totally cover yourself and make the upfront investment cost a lot cheaper. And then this is the exact opposite of the argument that Tony Seba makes. He says, no, just go ahead and do the thing that's 4 times bigger to begin with. And then you've got all this extra, 95% of the time that is super cheap to operate.
If you've got a useful need for that power that you're otherwise wasting, then I think Tony Seba's point makes sense. And honestly, in the very long run, I think we will get to that point where we've just overbuilt. But I think this conversation today is like, what's going on in the next 5 years with how like this ridiculous amount of new demand that we have? Nobody's really thinking about what to do with the extra power at this point. So like, I think in my view is like, the hybrid kind of approach like Jordan has it at his house. I think we're going to see more data centers coming up with kind of creative solutions like this, where you can say, okay, and honestly, I'm skeptical that we'll see much solar just because of how land intensive that is. And typically a lot of these data centers are like near urban centers where land is, a bit more expensive. So I think to the extent we're seeing co-located generation, I think it's probably going to be natural gas for the most part. But there could be one-off exceptions to that. You could have co-located like nuclear, for example, like that Microsoft scenario. So I think there's a few different ways that this might take off, but I do think kind of like hybrid solutions are going to make a lot of sense.
If only there was a company that was really good at building low-cost tunnels, especially, if that tunnel could be much, much lower cost because it only needed to be 2 foot in diameter instead of, 12 feet. And then you could just have, your solar farm located, like you don't have to get that far away from an urban center to where you can get to cheap land. And if you could, do an underground power distribution instead of doing overhead, like you could sidestep all the permitting basically that goes on with, trying to put in overhead transmission from that 50-mile away location. I think there's an easy solution here from a technological standpoint to offsite that solar. And then it becomes a question of, can we source enough solar panels that are not made only in China? That's the challenge you would run into there.
Yeah, I do think though, and I've been talking about this a little bit lately, like solar is the cheapest on a dollar per megawatt hour basis when you look at the generation. But like when you get to the point where you want to take that power in that is intermittent and turn it into firm, the combination of batteries, and even if you solve these transmission constraints with like technologically innovative ways, I don't think there's like some massive benefit to going to like a pure solar or like 90% solar in most cases, just because like the demand and supply matching, like these data centers really they want to operate like this, and the solar every day does this, and so then you need to like, even just to match, then like your solar needs to kind of like be this big, and then you've got like the massive increase in batteries. And when you do the math of like putting those systems all together, even if you're doing some smart stuff and like optimizing the way Jordan was talking about, with some other natural gas or whatever, I think you're still going to be in like the roughly $100 per megawatt hour range for your firm power. This is something Jigger Shaw was going on a rant on recently on this one podcast I was listening to. It's just like, like we always think solar is like, $20 and wind is like $30 a megawatt hour. And like, we're always like throwing these figures around, but like, that's actually just not true. If you want to use it, like whether you're like using that and then paying for transmission and distribution and like connecting to the grid, it's like $100 a megawatt hour. If you want to like overbuild it and use batteries, turns out that ends up to being about $100 a megawatt hour. If you want to buy natural gas generation and do that on site, turns out that's about $100 a megawatt hour. So it's like, these are like rough indicative prices, and obviously it's going to vary a lot based on where you are and everything like that. But I think I've gone through a bit of a transformation in the way that I'm looking at this in my own mind, of thinking of like, what's the levelized cost of energy? I think with this current moment, we're trying to get so much power to these data centers, which need it at this particular point and at this particular load profile. You want to look at what's the total average delivered cost of power, not like, what's your levelized cost
generation. Yeah.
So in that world, is the most important variable by far having an interconnect access to the grid? Is that a fair statement?
I think that's like the platonic ideal. Like if you could get an interconnect in 18 months, like I don't think we'd be having this problem. Like the utilities would be building out a ton of new generation, and like that'd be fine. But I think the issue is like the time. Like now that the time has become almost more of a barrier to these companies that are wanting to compete in the AI arms race. Like you can't wait 5 years to get your data center up and running if you want to be at the forefront of the AI arms race. So I think time to power is making the interconnect a suboptimal strategy, unless there happens to be some unique situation with your particular site, which lets you have that interconnect more quickly than say 2 years.
So, and I forget who, I know you mentioned this earlier in the pod, and there may have been, I don't know if it was an all-in thing, but does this mean, so like for example, Detroit as an example, right? Detroit, is that the perfect use case? Yeah. You finally have something good coming to your end, even though your Lions lost in the playoffs, which we talked about before we went live. There you go. So does that mean that there's going to be a revitalization in places like Detroit, where they have all this manufacturing building capacity that has been vacant for a long time, that in theory would have those interconnects already installed, that these new companies can go in and basically transform these old car factories that haven't been used in decades or years, and instead turn them into data centers because they have direct access to the grid already? One would think that they would have had from the factories being there. Is that a good way of thinking about this?
I don't think it's quite that straightforward, because if you haven't used a factory in decades, then the interconnect agreement you have is most likely expired. So it's not clear that you can just go to like Flint and grab the old GM plant that was abandoned in the 90s and go and turn that into a data center. I will say some jurisdictions are trying to actively win some of these new data centers a little bit more proactively than others. So Ohio, for example, like there used to really not be any data centers in Ohio, and they are building out a ton right now. And AEP, who's the local utility in Ohio, they're doing a lot of innovative things to try to help bring new business to the state. So there still are some regulatory roadblocks. We're actually watching a couple of developments there pretty closely from a regulatory standpoint. There's a pretty important case going through their Public Utilities Commission right now that would essentially create a landmark new tariff, which not the tariff that's in the news these days, but like think of it as like an electric rate, which would allow for building of on-site generation for data centers or for other new customers. It would be a kind of big break from the way deals like this have been made in the past. But basically, because this situation is so unprecedented, they came up with a pretty creative solution that I think works. But it still needs to be approved by the Public Utilities Commission of Ohio. So, I think jurisdictions that want to be creative and welcoming to new business like that have opportunities to do so. But even those have like legal and regulatory challenges that are, not easy to just overcome in 6 months.
Matt, how much do you know about the public electricity market in Texas and how that is similar to or different from what they're trying to do in Ohio? Because like there's a reason why the Stargate location is here in Texas, out between Lubbock and Dallas.
So I'm pretty familiar. I actually managed wind farms in both Ohio and Texas. So as far as that, probably more familiar on the electric generator side than on the demand side. But yeah, largely ERCOT, the Texas grid is heavily deregulated. The Ohio market's a lot more heavily regulated. Like generators have monopolies, so you have to like buy your electricity from that monopoly that serves you in Ohio, and that's not the case. There's a lot more choice in Texas. But did you have a more detailed question on?
Yeah. So the question was, what is the environment in Texas? You say it's deregulated. What does that mean? Like, and then what is Ohio going to? Does that offer the same types of opportunities?
Yeah, so I think it's going to be different. So Texas being deregulated basically means that like you can you can set up your own like electricity sales company basically and sell power. You can basically buy power off the market and sell it to an end customer. In Ohio and in most of the rest of the United States, that's actually illegal. You have to buy your electricity from a regulated utility. And there's kind of pros and cons to that. I mean, the idea of a monopoly just like sounds bad, but like some of these guys are actually shady operators where like you can not really understand what you're signing up for and take a fully variable rate, and then all of a sudden get hit with like some crazy charge because electricity prices spiked to $4,000 a megawatt hour and you just didn't know because you're a consumer. So like there are some reasonable reasons to want some protections, but I think the way that they're deregulated. And this model that Ohio is considering are a little bit different. And maybe we can just talk about the Ohio proposal in a little bit of detail. Essentially, it's illegal for the utility, so AEP, to own on-site generation, like think of it like a gas turbine or whatever that's actually on the customer site, and then like charge that customer for that electricity. They are essentially proposing like a new tariff that would allow a company like Microsoft or Amazon to essentially guarantee 85% of their total projected demand. So let's say they're building a 100 megawatt data center. Microsoft would say, all right, I guarantee that I'm going to take 85 megawatts for 7 years. And that way, as you're paying to build out the infrastructure to support me, I'm basically making sure that if I decide not to build this, or if I bail after 2 years, the rest of the ratepayers in Ohio aren't going to get stuck with all those grid upgrade charges. So it's a pretty novel approach that they're taking to basically have this minimum guarantee, so that one of the main goals of the regulators is they want to make sure that whoever is causing the cost to be incurred is the one who's actually paying for those costs. And so this is a pretty novel way to try to assure that these hyperscalers that are like basically causing AEP to build out a ton of new grid infrastructure are actually guaranteeing to pay for at least 85% of it. So that's a bit of a novel approach. has faced some pushback because of how unique it is, and they're basically moving away from a lot of precedent in how rates like this are made. But a lot of the consumer advocates in the state are actually supporting it. Walmart actually supports it because it kind of protects their rates. So I think it's likely to go through, but it's a case we're watching pretty closely because I think it could be something that gives you an indication of where policy might go in the future.
Is there any indication at this point in time where AEP would be developing the electric generation capacity to serve those data centers? Did you say that would actually be that on site, that they would co-locate those with the data centers themselves? Or
yeah, so it could be. So they would have that this tariff would allow them to pursue it a couple different ways. One of the ways that they could do it would be on-site generation that AEP would actually own. So this would help to avoid a lot of the infrastructure challenges of building out new transmission and distribution, which could take 7 years. So if you want to avoid some of those issues and actually build on site, AEP will build, own, operate it, charge you this tariff, and then that's a way of kind of minimizing some of the costs to the rest of the grid. So yeah, they're actually following these two different regulatory filings at the same time. One is kind of on shaky legal ground, I would say. The other, much more likely to go through, is on much firmer legal ground. I won't go into all the nitty gritty, nerdy energy regulatory reasons why that's the case, but it's pretty interesting, and I think it's something that just makes sense on a purely logical standpoint, and I think other utilities should be looking at this as a potential model.
So that co-located site from AEP, so the one that's right next to the data center that they are going to build, and they'll tariff the company. So would that be also connected to the grid, so that let's say they overbuild capacity, then that generator of power can then supplement the rest of the region over the long term? Or would it just be specifically designed just for, let's say, Amazon?
Yeah, so I think it would be specifically designed for Amazon, but I believe it would be connected to the grid. Generally, it's better for all parties involved if more assets are connected to the grid than not. So you might have it's possible you could have some situation where, let's say, because of the transformer shortage, maybe you can't get it connected to the grid for 2 years or something like that. Or maybe there's an interconnect study that's going to take 4 years. So you can set it up on site with the goal of connecting to the grid eventually, but AEP can at least get you the power from this in the interim. So there's a couple different ways it could logistically work out depending on the site specific situations. But to me, having the utility actually own, operate these sites, get them up quickly, and then kind of work on all the regulatory, the interconnect stuff on the back end, I think that's just a win-win.
Got it. But it is very much state driven. So that could work in Ohio, but in Texas, it could be a whole different thing. It could just be, all right, Elon, okay, Tesla, we're just going to create our own power now. Fuck it. Yeah, we have all this land. Let's go.
Memphis, yeah. I still don't really understand how they got that interconnect to be increased so quickly. That was just something particular with, either the regulators there or Elon pulling some political power. I'm not sure, but one of the frustrating things about the energy sector is so much of this is location specific. It's hard to talk about trends, especially on the regulatory standpoint, because it's so location specific.
Do you think there's going to be grounds for a federal framework, just like how autonomous vehicles? It looks like the Secretary of Transportation is starting to push for a federal framework for autonomous vehicles. Do you think one for energy and power generation would be helpful, or do you think that's too invasive in state rights? How do you view that?
So I think it is helpful, but just as one example, so FERC had this landmark ruling. I think it was Order 20. So the Federal Energy Regulatory Commission. They had this ruling 2222 5 years ago, I think it was. Basically creating a framework to incentivize more build out of distributed energy resources. So, this kind of co-located power that we're talking about, for example. Well, okay, they had this order, and that's great, but then they had to go through to all the different ISOs, the integrated system operators, basically the grid operators, to say, okay, FERC had this order, how are you going to go and implement that in your own, jurisdiction that you're managing? And so then that was, multiple years of, them figuring out how they're going to do that. And I've kind of lost track of what's happened since, because it's just like, there was this landmark order and I was like so excited about it 5 years ago. And then I look at like, okay, so like, did that actually do anything? And I'm sure some energy wonk could tell me specifics, like a few specific instances of how this, federal framework
I didn't know energy
changed a
wonks
couple
existed.
Oh, they do. I listen to some podcasts. I can. There are some nerds out there, I'm one of them. But like there are some people who follow this stuff in a lot closer detail that are great to listen to, actually. So like it can help, but like so much of energy is regulated at the state level in multiple ways. Like it can be state environmental agencies, and then there's like the EPA, and then you've got like the grid operator, and then you've got the Public Utilities Commission, and then you've got like local permitting that you need, and like NIMBYism that's preventing a lot of build out. So like you get regulated from everywhere. So like even if you had the perfect federal framework, you're still going to have a lot of these other issues. And like I think one of the biggest issues right now is the interconnect, and that's these ISOs, which most people don't really understand how they are. They're like regional networks, or in Texas's case, it's ERCOT, the grid operator there, that just tend to move slow and have this way of doing things. And they're nonprofit organizations that like are doing the best they can, but like their main goal is to make sure the grid doesn't fail, and their main goal is not to like accelerate the advent of AI through a faster interconnect process.
So there is a forcing function right now for states or localities that have very low regulations that would enable the fastest on-ramp to doing a co-located power generation facility for these data centers, right? So it's like, it seems like that's like the best case scenario, like a Texas place, sort of alluding to Hans's question. It seems like Texas is extremely well positioned for a lot of these companies to put their data centers here. Number one, because a regulatory landscape feels like the best, or one of the best, let's say. But number two, you also have a lot of sun. There's a lot of sun down here as well.
A massive amount of wind power too, and like that was actually one of the problems with the Texas grid in general, is like you had all this wind in the panhandle, and you'd have like negative prices because there's not enough transmission capacity to get it to the city centers, to the urban centers. So yeah, I think Texas is actually in prime position. That's why you see Stargate being built there in Abilene. I think there's a lot of reasons for that, but like, yeah, the regulatory environment in Texas is much better than most other places.
So how familiar are you with how that came about? Like, has Texas always just been relatively deregulated, or was there deregulation that happened specifically to deal with, I don't know whether it was the installation of these massive wind farms, or like, is there a correlation between those things?
Yeah, so I don't know all the history of why ERCOT is set up the way that it is, but I mean, like I can just give you an example. So I was involved in development of a wind farm in Ohio, and then about a year later, we developed a much larger wind farm in Texas. And like the amount of environmental reviews we had to go through in Ohio was like kind of crazy. And then we ended up having to curtail, meaning like basically just dump power for about like, I want to say it was like 5 to 10% of our overall power generation. So that's like 5 to 10% of your revenue just gone because of a endangered bat that might get hurt by the blades when they're out at night. So depending on certain wind speeds, so like direct decrease in the project's revenue, and then on top of that, we had to hire this company that was like 3 people walking the different turbines every single day for like 2 years, I think it was, collecting every single bird carcass that fell, identifying it, freezing it in case the Ohio Department of Natural Resources wanted to come and see which birds have been killed. The whole reporting apparatus that went along with that, like obviously very expensive to to do all that. And then it went to Texas, and it was just like there's no regulations. I was like, oh, like none. They're like, yeah, you don't have to you don't have to do any bird studies. You don't have to change your operations and have that reduced revenue. And I'm not going to advocate for one or the other, because honestly, there are pros and cons, but that's the difference. Just on one small example is just the environmental side it just made it so much easier.
So Texas is super primed to vastly benefit from where we're going in the next 5 years. That's the picture.
I mean, honestly, I don't think Texas is going to be the only winner, but I mean, I think there's a reason Stargate, which they want to be a 1 gigawatt data center. They obviously chose Texas for a reason, and I think there's a lot of things going right for Texas.
So under any,
it's gonna be everywhere.
Under any scenario that we run into in the next 5 years, as far as on co-located, making sure that interconnects are ramped up, dealing with regulatory, et cetera, it still seems like on-site storage of some sort of energy storage it feels like it's going to be a huge part of the equation, batteries, to try and manage all of these different loads and be able to utilize solar and be able to utilize wind wherever possible. Do you feel like this is a huge boon for energy storage? Like specifically, if we're talking about Tesla, is the Tesla energy sector and the just battery sector period going to benefit tremendously from this AI push? How are you viewing that from your perspective?
So I think so, and I have to say I think so because I'm not in the data center space actually building these out. So I'm trying to read and research a lot to kind of stay up to speed on what the priorities are of the companies that are doing this work. But from what I can tell from following these voices is having 99.99% uptime is pretty much the required norm. That's why even for grid connected data centers, most of them will have diesel genset backup power so that they can keep going if the grid fails. Because the grid doesn't operate at 99.99% availability. I mean, if you've got a couple hour power outage a couple times a year, then you're more like maybe 99%. So you're very far off the goal that these data centers want to have operating. So, I think most of the data centers now don't use mega packs or, massive amounts of backup power the way that, the Colossus does. But to me, it stands to reason that, those will become more and more in use. I mean, one, just to have the extra reliability, but two, because of that issue we spoke about earlier, where let's say your interconnect limit is here, but through your connection with the local regulators and the grid operators, you have some buffer where you can operate within a broader window than just one set number and that's it. So if you have a little bit of flexibility in the way that you're operating your data center, that's going to lower your overall cost of the energy that you're delivering. And I think the only way you can do that, maybe I'm wrong, but it seems to me that the only way you can actually have that level of flexibility is not by randomly just turning off a rack of GPUs. That's gonna be very hard on the equipment. I think what you're going to want to do is buffer with mega packs or with some short to medium duration pack, so that as you're basically told to power down because there's a great emergency or we just need your load to come down for whatever reason, you can do that in a gradual way that is conducive to the way that you're actually operating the data center and won't just be a big shock to the system.
And there's a third thing, which you may have covered in there, but these GPUs require, there's huge fluctuations when you have thousands or tens of thousands of GPUs connected together. And you're going, there's a quote from Elon where he said a couple of years ago, we were having some power fluctuation issues. When you do synchronized training, it's like having an orchestra and it can go loud to quiet very quickly at the sub-second level. The electrical system can freak out about that with 10 to 20 megawatt shifts several times per second. So you need these battery packs when you have these large data centers just to provide those short bursts of power.
So why does that happen? What's the mechanism that causes that crazy shift?
So what's happening there is you've got, what these GPUs are is computers that do massive amounts of matrix multiplication. And so it's just like, if they're synchronized, they're all doing their matrix, like their adds or their subtracts or their multiplies at the same time. And then once they've done their calculation, they're sending the numbers, the results off all at the same time, then to be stored and prepared for the next sequence. And so like they're all doing math at the exact same instant, and then they're all stopping doing math at the exact same instant and waiting and kind of going into this power standby. And it's actually interesting because there are some people who have solved the same problem by just saying, okay, while you're like, once you do your math operation and you're waiting to get the next thing back, just continue to do 0 times 0 or 0 plus 0 or whatever in the meantime, so that you continue to draw the same amount of power constantly, and you're not like doing them and then stopping and then waiting and then doing them again. Because that's like, there are interesting workarounds to this problem both ways.
Sorry, Jordan, I didn't mean to interrupt you.
No, that's all good. Hans did a better job summarizing it than I could have. I forgot about those extra programs that they were operations they were programming in that basically just burnt power to keep the power and energy levels steady. So yeah, my view is that these batteries solve multiple problems at once. So we're going to need a whole lot of them.
Yeah, and so just for my stupid brain, so then the battery mechanism then for these like crazy shifts is that the battery can absorb those crazy shifts much better than the grid can.
Yeah, there's nothing else that can respond in those respond at sub-second speeds, and also do like 10, 20, solve 10, 20 megawatt fluctuations. I think is like at Memphis they have like something like 100 or 150 megawatts of battery packs, and they have like a 300 megawatt interconnect, something like that.
Yeah, those instantaneous bursts are like, they're very hard to manage, especially at large megawatt volumes like you were talking about, Jordan. I mean, so with plants I used to operate, like you can ramp up and down maybe like 20 megawatts over 15 minutes or something like that. In the grid, in aggregate can absorb that a lot better than any individual plant. But when you start getting to 10, 20 megawatts instantaneously, that is very hard on the grid. And it's very possible that you can have equipment fail with spikes like that, especially if they're happening on a regular basis.
And the benefit of solving it with batteries, instead of just telling the GPUs, okay, do a whole bunch of worthless, like throwaway math in the middle, is that, Jordan was correct. It uses a lot more power than is necessary. It's very inefficient. Like you're just burning electricity that you don't have to burn. So if you can solve it with batteries, then like you could probably close to pay for your mega pack just in energy savings. And you get to then, you have to build a lot less energy capacity to operate your data center to begin with. Like it reduces the overall amount of power you need.
Is there a specific
to accomplish the same results?
Is there a specific battery chemistry that does that better than the other? Like absorbing and releasing energy quickly, or are they all the same?
No, they're all pretty much the same, because you have this huge energy. A battery pack is, think of it like a dam, damming a river. So you're just pooling all of this energy and keeping it in reserve. But a dam, if you want to spool up those turbines in the dam, it takes time for them to wind up. Whereas a battery, it can do it in split second levels.
Got it. So it basically has a door that teleports in and out. Basically, it's like the dam wall, and the wall just, you can make it disappear and then it just comes back like a hologram.
Yeah, and that's what these computer chips and what the electronics in these inverters do. It's you're talking it's moving at the speed of compute.
Jordan, is it fair to say though that you probably, all things considered, would want short duration, like 2 to 4 hour storage rather than say 8 or 12? Because with 8 or 12, like your capacity relative to the size of the overall storage amount is going to be a lot more limited. So to me, it seems like lithium ion, just from like the price, per kilowatt hour, like how much capacity you get, meaning how many kilowatts you get for a set dollar per kilowatt hour price, to me, it would seem like it would favor shorter duration. But I'm curious if you would agree.
And help explain the difference, like the mechanical like difference between short and long duration.
Okay, this one is a mind bender for me, so I might need a little bit of assistance. But
Do you want me to
if you want,
here's my
okay.
dumb version. So, when you use batteries, you have an amount of storage that is measured in kilowatt hours, correct?
Correct.
Okay. So, kilowatt hours, 1 kilowatt hour is you use 1 kilowatt of electricity for 1 full hour. So you can either use or store it. So when Matt is talking about long duration versus short duration, he's saying, usually these systems come in like 2, 4, or 8 hours, I think, something to that effect. So a 1 kilowatt hour system that is 2 hours can supply you with a half a kilowatt for a length of 2 hours. Whereas if you wanted 4-hour duration battery, then it can only supply you with 250 watts, or a quarter of a kilowatt, but it can do that for longer. It can do it for 4 hours. So you end up using the same amount of power. It's just that you use it over a longer duration of time, but the amount is lower per hour. And so so then what Matt was saying was, if you have these big spikes in power, then you want a system that's probably shorter duration, because then you get more watts of dynamic range that it can go up and down.
And when you're looking at these battery storage systems, it's like, well, couldn't you just discharge the batteries much more slowly? What is the gating function here? What is actually causing that duration? You can take the same batteries and you can make it a 2-hour discharge system or a 4-hour discharge system. So what's the difference between those two sets of batteries? It's not the batteries, it's the inverter. What's the ratio you have of batteries to inverter? And that affects the cost of the system. But you also have to look at, all right, well, how long are these batteries going to last in terms of calendar life and things like that? So you get into all these minor cost functions. If you have a data center, my view is you'd want something that's shorter duration, because you'd have greater inverter capacity, so you can deliver the power that you need for those spikes. But also with batteries, there's going to be a certain time period in terms of calendar life where they're not going to last 15, 20, 30 years. So you want to discharge and charge them as quickly as possible to get the maximum utility for a certain amount of time. Matt, is that correct?
Yeah, I think you both summed up kind of the question, and I think generally I agree with all that thinking. I mean, the way I was kind of thinking about it as you were talking about it, both Hans and Jordan, was like, let's take the Colossus Center for data center just as an example. I mean, let's say you've got like your maximum instantaneous draw you might need at any given point is like 50 megawatts. Let's just say as an example. Well, if you want an 8-hour storage system, that means you need 400 megawatt hours of capacity, and like that's kind of dumb, because you're not going to be discharging for 8 hours straight, and probably on the total dollars that you need to spend on that 400 megawatt hour system is probably more than a comparable 2-hour system in terms of like total dollars that you need for the system. Because really what you need is the capacity, not the energy storage pie. You care more about the inverters, to your point, Jordan, than you do about the total kilowatt hours that you have in the tank.
Okay. But that also means that the buffer you have to power is also smaller, because you have a smaller battery with a short-term duration one, right? By default. And so you need some sort of, yeah.
So like I'm guessing maybe maybe 4 hours is best. I'd actually be curious, like somebody who's more familiar with the Colossus site, like what did they choose? Because especially it also depends on how much like flexibility you have. Like if you're only using it for instantaneous power, my guess is 2 hour would be fine, maybe even 1 hour, because like you'll like cover that blip and then like recharge and then like cover that blip. If that's all you're doing, you really don't need like multiple hours, I don't think. But when you're getting into a scenario where the local utility is saying, hey, we need you to bring you down by 20 megawatts for the next 3 hours. Well, okay, well then having some duration is pretty valuable. If it gets much beyond 3 hours, I would suspect you're going to change the way that you're operating and probably bring down some racks. But you can do that in a controlled fashion with a 4 hour time frame. Probably I think that would be enough.
And what makes this such a challenging and interesting problem is each site and each location is going to be different. And it also depends on what tools you have at your disposal. Like, for instance, when I'm looking at the power system in my house and the energy system in my house, it's like, well, what's the best ratio of solar to batteries to gas generation to how much that I pull from my interconnect at my house? So it's like, well, you can solve these problems through different mechanisms. The way you decide how you balance each of those things out is you look at what's the cost of each of those components. So you just look, all right, here's my menu of things that I can use to provide power and energy. How do I pick and choose the amount of each one to provide the lowest cost solution? Or in the case of a lot of these new AI data centers, what's the solution that gets me there the fastest and not necessarily the cheapest? So it's this complex puzzle.
What a crazy time that we live in, if you really think about it. This is like unbelievable. Where like we're literally nerding out on how to create power for an AI data center. What is that?
Hopefully we're the last generation that has to worry about this. Our AI overloads floors will say, this is a super easy problem, you idiots.
Yeah.
Obviously, it's 3.14 hours of duration that you need at this particular location, and you need a 13 megawatts
at 42
of natural
megawatts.
gas. Yeah.
So I think this does highlight, like, we have the mechanism to solve these problems. It's called a market. Like, the market does this kind of magic complex adjustment on the fly all the time. And this is why the Texas system is probably one of the best systems in the United States right now to do this, is because the energy market is the most free market option here in the US. But this is also another reason why other nations that want to be more free market when it comes to grid operations potentially have an opportunity to surpass us. Like, this is why, I don't know the complexities and the ins and outs of how China plans to grow, their electric capacity from, I think they're planning to go to like 8 terawatt hour or 8 terawatts here in the next few years. But I would anticipate they're probably using markets to help solve the allocation of those, like what stuff gets brought in, where it goes, all of that stuff. I mean, they use free markets a lot when they are trying to bootstrap a new industry, even more so than we do here in the United States a lot of times. And so that's just, I think if we think that we're going to solve these problems by running away from letting the markets do that hard work, I think we're going to be setting ourselves up for failure.
Yeah, whenever there's an extraordinarily complex problem, it's markets are generally the best way to solve it, in my view. This isn't something that you can do very efficiently top down. You can encourage it with subsidies and things like that, but
and the thing that sucks about markets is you do get the situations where Matt was talking about, where like, wait a second, now your price per kilowatt hour is just going to spike to some insane level. Well, the reason that it spiked to that insane level is because something broke and it needs to be fixed. And that price signal tells you, hey, go fix that thing. And if you don't allow for the price signal to get crazy, then you lose the pain that tells you what needs to be fixed next.
It'll be broken forever.
Yep. It will be. So that's the, like, it's not a magic solution. I mean, it kind of is magic in one way, but it's not a pain-free magic solution.
Yeah, I was last year. I was at the Michigan Tesla owners meetup, and somebody was pushing on this question. They said, with all this extra energy that we're going to need for data centers and vehicles and things like that, isn't this going to spike our power prices? And I was like, well, yeah, it will, but that's going to, the market will resolve that. And if you try to get the government involved to try to fix it in the long term, it's going to end up being worse. This is something that you really can't prevent. You just, as you said, when you start encountering a problem, that creates a price signal that resolves the problem. And if you get government involved, generally what it'll do is it'll scramble that price signal even more, and you end up with even higher prices in the long run.
The most hilarious thing of this whole thing is that I remember people were freaking out so bad about EVs. Like, EVs are going to destroy the grid. What's funny about EVs is they're probably providing more like load balancing than anything, because people are plugging in and charging at night, and so these utilities are going to be able to be a little bit more efficient. But then the thing that's really going to make it explode is AI. EV is nothing within the context of AI.
Yeah. On the price signal point, like, I am a proud capitalist, and I completely agree with what you guys said, but I do think the energy market is different from a lot of other markets in that consumers don't see real-time prices. So, like, I mean, in Texas, if the prices, go up to $4,000 a megawatt hour, you need some sort of mechanism to let the consumer know, or to automatically adjust behavior, because, like, it's just like, you're not going to be like watching the real-time power map and be like, oh, I'm turned my AC down like 5 degrees because prices are a little too much for me right now. So
we need like an Amber Alert for energy.
Well, yeah, like, and that's why. But I think that's why these markets have evolved this way, because, like, it used to be the case that literally you had no idea when people actually consumed electricity, which is why, like, there's literally a guy that would walk to your house and read your meter, and they just knew that within the last 1 month you consumed 213 megawatt hour or kilowatt hours. They had no idea when. They knew what the system was doing in aggregate across all demand, but there was no way to individually price people in a real-time basis. So that's, like, I think the technological reasons why this market has evolved this way are kind of important to keep in mind. And as we go to a freer market, you need some way to get price signals from wholesale markets to the retail market. You've got like some programs in California that like do some stuff to, like, if you have a Powerwall, then like you get paid a set amount, but that's not really real time. That's like a program. What I think would my real goal is that you get like some people to aggregate Powerwalls or other home energy devices and basically choose to operate them in the most efficient way possible, including by acting as generation. And I was actually going to ask you, Farzad and Hans, like, if you've got a Powerwall right now that can provide value to the grid during an emergency, or when like power prices spike up to like crazy, can you actually get paid for that at real prices right now?
I don't have a Powerwall, I don't know, but I don't think that's allowed.
I'm
free markets.
not on
Come on,
ERCOT. I'm on SWEPCO, and so yeah, I think there are programs like that here in Texas. I think they're still kind of localized. They haven't rolled them out across everywhere. But yeah, like right now, if I was to have solar, like, I don't have solar or Powerwall yet, partly because SWEPCO will only credit me like 2 or 3 cents a kilowatt hour. They do like a generation offset if you send power back to the grid. And but yeah, it cost me like 12 or 13 cents a kilowatt hour, but those rates are pretty much fixed. It doesn't matter what time of the day that I'm using them. So, like, I don't know, we're a little bit more rural here and less of a dynamic market.
Yeah, so we're underutilizing these assets, because, like,
yep,
if there's a grid emergency and prices spike to $4,000 in Texas, but like, and you have a Powerwall that's got 10 kilowatt hours, like, you should absolutely be getting paid market prices for that. But there's not even a mechanism to like put that into the grid to help with that situation, which is just good for society and good for the Powerwall owner. So it's an endless frustration of mine that these markets are underpaying distributed energy resources and underutilizing them. It's not even a matter of underpaying. Like they can be a much bigger part of the solution than they have been historically.
And they're
like everything's there.
And they're under incentivizing load shifting. Like, for instance, if I had variable power available to me here at my house, I wouldn't even have put up the solar panels. I just would have built a battery bank, and then I just charge them up at night and discharge them during the day. And it would have saved me a lot of money, and the system would have paid itself off more quickly.
So obviously, homeowners. Oh, go for it, Farzad.
No, sorry. So I grokked the Texas situation. So you can get paid for that Powerwall energy in Houston and Dallas, but not Austin and San Antonio, and it's different depending on which speaks directly to the cluster.
But yeah, so like obviously, individual homeowners, you don't want to be watching when the power is more expensive and when it's less expensive. But what we are talking about is expanding that free market to include homeowners, and then for them to be able to have some sort of system that exists at their house that looks at what the price signals are of energy at any given time, and then either consumes or returns energy to the grid based on those price signals. And that can be something that's completely run in software. I mean, that's what these virtual power plants that do have these power walls at people's homes in Dallas and Houston are doing. Is that like, hey, we had a tree fall over here in this neighborhood. It knocked out power around this area, and all of a sudden prices spiked up, and then a whole bunch of power walls, for 5 miles around, all just instantly responded and supplied power back. And the homeowners that had that, they made their electric bill for the month was negative $50 instead of $300.
Yeah. Okay. Anything else?
Matt, where, like, Elon has talked about do you guys still have time? Okay. So,
cool.
I didn't realize we'd started yet.
Yeah.
All right, record.
There was a whole bunch of things going through my mind throughout this conversation. I was just, but I was also interested in listening to all of the detail that you provide with how these markets actually work. So, Elon's mentioned building a 1 terawatt of compute. What do you think he has in mind for that? What do you think that is the best path to achieving that?
Yeah, always a bit of a tricky ask to look inside Elon's brain when he's at like the very forefront of some new idea that he's had. But as best as I can kind of put it together, I'll try to lay it out. So,
can you do an impression of his thoughts as you do?
No, I haven't. It's been so long since I've done that. Maybe at the end I can try to wrap with something like that. But I think when I'm trying to actually think through what he's actually saying, it takes too much of my brain power to go for the Elon imitation. But we've seen these data centers go from 10 megawatts to 100 megawatts, and that was really big a couple of years ago. And now there's multiple companies doing 1 gigawatt data centers. Total U.S. capacity is about 1.3 terawatts, which is 1,300 gigawatts. So we're going from this scenario where 100 megawatts used to be big to 1 gigawatt's going to be standard pretty soon. And then I think one of the things that I don't think I fully appreciated until recently was it's not just the training. I think I had in my mind this kind of mental model that all right, you need to train the next GPT or the next FSD model or whatever Optimus, and then you can basically keep iterating on that and you'll be fine. But what's actually happening in the real world is that people are using these resources so much that that's what actually a huge amount of the data center load growth is from people who are actually using these tokens to, at first it was generating text, then it was maybe generate an image, and that's a lot more compute that you need to generate an image. I don't know if you guys saw this the latest video drop from Google, but these videos that it can create are insane. And think of how much more compute that takes compared to text. 10,000 times more, I would guess. I actually don't know.
So it's $1.50 per 8-second video.
Per 8 seconds. And so what does that compare to a normal chat GPT request? What would it be, 10 cents maybe?
A fraction of a penny.
Yeah, a fraction of a penny. Okay, yeah. So massive increase
for
in
GPT-4, 4 mini or whatever. Yeah.
Yeah, not O3 with deep research or something. But so like the average compute that a user was using has increased, I don't what 10,000x in the last couple of years, which is not something I had on my roadmap. And so then like it kind of stands to reason that like I wouldn't mind doing a couple 8-second videos, or like maybe I want to do a 10-minute video down the road. And then like you can have entertainment that's actually customized to you. I mean, this is something that we've all kind of talked about in the past of like, what's the perfect movie just for me? That's like going to be insanely compute intensive. And so like, you know, it's if the latest state of the art is a 1 gigawatt computer or a data center, and you need 1,300 of those to basically equal the entire electricity output of the United States, given how much increase in demand we've seen as the capabilities have got better and better, it just kind of stands to reason to me that this is going to be something of a vicious flywheel where the capabilities it delivers us are going to get so much better that demand for those products and for those answers is going to increase exponentially. And that's where I think we're going to get in this kind of crazy flywheel where like you're training Optimus and you're doing customized videos for yourself and like asking, you know, questions, and like you've got your own voice assistant. Like all this stuff is going to be very compute intensive. And I think it just stands to reason as adoption goes from like, honestly, I think the four of us are probably pretty big early adopters compared to the rest of society. And so even if nothing else changed, but that, you know, the rest of like the 95% of society who's not using it as much as us, if they just adopted the current state of the art, well, like that's a massive increase in compute needed. And if the capabilities extend, then overall demand, I think getting to a terawatt, that sounded crazy when I first heard it. But then when I actually started thinking about it, I was like, oh yeah, actually it doesn't take a whole lot to increase by a few orders of magnitude, given how quick this is evolving. So I don't think he's talking about a 1 terawatt individual data center, but maybe like in aggregate, we're going to be at a terawatt and maybe blowing past that way sooner than maybe we were considering before.
And we should remember that we've been through this process before, as far as like the internet started out and pretty much the only thing you could do was basic text because bandwidth was limited and it would take forever to load on your screen. And then it's like, oh, hey, we want to do images. That's, you know, way harder to do than these like single color screens with very basic text. And then, oh, hey, wouldn't it be nice if you could do video on the internet? Well, yeah, you can, but, you know, it's going to be really slow and you're only going to be able to do a couple of seconds. And then now, like, you know, you play that forward, eventually you get YouTube, and like now you can just have like video on the internet for free in mass, like uploaded at bazillions of hours a day.
I vividly remember thinking how cool it was that I could, within 15 minutes, download a 2-minute trailer and watch that. I was like, this is amazing. So you're absolutely right, Hans. Like we have gone through this before, and it's like, it's oftentimes when you're at this inflection point, it's hard to extrapolate like going from text to video and how big of a leap that is. But it really is a massive leap in just compute needs and everything.
And we're not even talking about like okay, human or robots. How much computer are they going to need to learn how to do stuff? That's like,
everything is computer.
Everything is computer. It's so true. It's crazy. It's freaking crazy. I was playing around with the VO3 yesterday, and it's legit, man. You guys should use it if you haven't tried it. It is expensive, but it's amazing. It's amazing. It does. Can we show you one of the trials we did with a stand-up comedian?
Yeah.
Should we do that? We'll do one live? Yeah. So actually, we'll do it live here. What Bill O'Reilly's famous words? Fuck it, we'll do it live. Here.
So did you ask it to like do a video of you but with friends?
No, it couldn't figure out how to do that. It was like prompt misunderstood. I don't understand what you're saying. You don't have any friends. You're a loser. Okay, so here's the UI, new project. Okay, and there's you want to select VO3 under the quality, and it gives you 2 different outputs. Okay, okay, so let's do a text to video. So give me, and it comes with audio too. This will have audio as well. So, what do you guys want? Give me a prompt.
So I'm just remembering one that I gave to Sora a while ago that was horrible, and I'm kind of curious to see how it does here. It was a regal crab walking through 1920s New York City.
As you
Is
do.
it saying something or no?
Oh, yeah, that's probably not a. Yeah, sure. Talking about its privileged position in society.
I misspelled privilege. Okay, so it has two different. It will give me two separate ones. So while it's going, and you'll see, and it will have audio. It will have. It is so, dude. It's so good. You're gonna be shocked at how good this is.
I'm glad you're showing it because I've been curious about how long this takes and how it works. So
yeah,
thanks for showing this.
And you can add scenes as well. You can like create a movie and you can ask it to do different.
So you're
scenes.
like a director, basically.
Literally a director. We'll do it live. Maybe we'll make this the clip from the podcast because this is going to have some broad-reaching potential.
I should.
And it's relatively.
I'll share what the output I got with Sora too, because it was like so bad. Like
yeah.
It was just like this crab that was like sliding.
Do you have it?
I could probably try to find it while it's pulling up. I mean, this was a couple months ago, so it's probably not the latest and greatest. But I don't use Sora because it's not good.
Sora is garbage. Okay, OpenAI. Like still don't understand the value proposition. I don't want to turn this into that, but I don't get it. Now
deep research is phenomenal. O3 with deep research helps me a ton analyzing new companies, industries. It's excellent, actually.
What about, have you tried Grok's deep research?
I find Grok's deep research is not as deep as O3's deep research. Like it's like maybe helpful to get you kind of up to speed on something, but it's not going to like go really deep and help you understand like at the level that I want to be going on a topic.
It's not autistic enough.
Yes, exactly. That's exactly right.
So
what about Perplexity?
Perplexity, so it's been a while since I've used it, but it's really good at like finding financial data. So like if I'm looking for, I don't know, like an income statement of a company over the last couple of years, rather than like build it out myself, which is what I used to do as a financial analyst. Perplexity does a really good job of finding stuff like that without hallucinating. So yeah, I like Perplexity too. Okay.
Do you use Grok for anything?
It's the best for current events. So if something's like happening now, I'll go to Grok.
Okay. But I wonder how defensible are like Perplexities and ChatGPT's moats. You know, it's like what's the secret sauce of ChatGPT?
I don't think it's
the user base, the network effects of consumer mindshare.
We don't have to talk about that. So, do you have that video, Matt? Should we watch yours first?
I do. Let me see.
So it looks like Vio has already generated 2 of them.
Let me see. How can I share this? Let me see if I can share my screen. Pull this out.
That's what you said.
Not me.
Yeah, your 19,000 kids say otherwise, I guess.
So, can you guys see that?
Let's see. Move add to stage. Okay, go ahead. Play it.
Okay, so the prompt was a king crab dressed regally and wearing a crown walking down the streets of NYC circa 1910. Something.
What? No way. That was a video?
This is what Sora, and I was like pretty excited about it, but then I saw what it did and I was like, okay. The legs aren't even moving. That's what you did.
Okay. Should we do VO3?
Yeah.
They gave me 2. All right. So here's the first one.
Whoa, I like
it's a privilege indeed to simply stroll amongst the commoners. It's a privilege indeed to simply stroll amongst the commoners.
Let me go ahead and do this one.
One must never let the lower classes gain too much power.
What do you think?
One must never let the...
obviously better, but you would have expected other people in the video to be moving or something. So that's my only complaint about it, but obviously way better. The second one was a lot better than the first one too, I would say.
Yeah. The really freaky ones are the like we did one with a stand-up comedian. Look at this one.
You know, Elon Musk is so rich, he could probably buy a new Twitter every week and no one would notice.
A dog shit joke, but get the point. This one.
I mean, who's naming a car Cybertruck? I feel like he went on a bender and woke up with that name.
Or like tell a joke about Elon Musk, and that's what it looked like. Yeah.
I thought it was set the scene as like a mediocre open mic night. It's pretty compelling if that was the prompt.
He said, I know more about ISIS than the generals do, which is like saying, I know more about bird migration than the birds. He said, I know more about ISIS.
So the video quality is really good. I think comedians are going to be safe for a while, but like it's extremely good. And pairing audio with it is, I think, really impressive.
Fake tears. But like the facial emotions are really, really impressive with this.
I mean,
this is what
it's striking that the things that you pick out about the video have nothing to do with the quality of the video itself. Like, it's indistinguishable. At least on it, like you would need to have a big screen and high def and like look closely to be able to tell that this is not legit.
Yeah, I mean, there are some very tiny little like clues. I don't think this was the highest quote, but that's really good, man. You know, and the animated ones are the ones that are like the super super impressive from what I found. So like, if I say like animated scene of people playing soccer, overhead shot, super action packed. I don't know, something like that. And that's where this gets like, but to your point, like the compute needed for something like this is like compare the compute needed to process that versus the compute needed like a year ago for like Baby Sora or whatever it was.
I think we easily need 1,000 times more. And like Colossus is going to be 1 gigawatt. So, I mean, as you're pointing out earlier, maybe 5% of the population is really using this. And it's mostly like language rather than video.
Way less than 5%.
Yeah. So you increase the number of people that are using it by 100 times, and the tasks that they're using it for use 10,000 times more compute, even if it gets a lot more efficient, which that's often the counter argument. Efficiency is going to fix that. It'll fix, maybe a couple orders of magnitude, but not 5 or 6 orders of magnitude.
Yeah. And I think if it becomes agentic and it's always working for you in the background, then like all bets are off too. I think like then you can get to just like completely nutty levels of demand. So yeah, it's kind of hard to believe, but like the electricity sector might be one of the most exciting sectors to be a part of right now, which is like the exact opposite of what was the case when I worked there.
I feel like end of next year, I think the markets will be like actually true believers of this stuff. Like it's going to be so obvious. So I wonder if like these energy companies, your Teslas, your Amazons, your like your Googles are going to start getting some heavy forward multiples because it feels obvious. The demand for this stuff is going to be unbelievable. Self-driving cars, VO3, whatever, just agents. Anything that touches an AI thing is going to become massively valuable because of how much better it makes everyday life, and how much more fun.
Yeah, it's only the beginning. People think we're already in or maybe at a place where the AI bubble is going to burst, but I don't think it's really hit yet.
We're at the beginning.
Yeah.
Yeah. I mean,
we're at the very beginning.
Jensen has been talking about, how tokens are, kind of this new fundamental unit that the Industrial Revolution is essentially an entire global transition to using electrons to do work through all sorts of different means, whether that's using electrons to send information through telephone wires over long distances to then being able to do
That's terrible.
That's awful. To being able to, do useful work, like you get electric motors and you replace, or, you start with steam engines, but then eventually you get to where you can use electric motors to do all kinds of stuff. And so we had that. Then we had the, tech revolution where we invented computers. We get these things called bits. Then we connect everyone to the ability to create and transmit and send bits back and forth with the internet. And now we have these tokens, and tokens are like the electrons of thought or the bits of internet. And like, there's going to be a whole AI industrial revolution around, what can you do with just a massive increase in the ability to generate thought. And that will be both, disembodied with all sorts of things that are just live purely in the cloud. But then since we already have all of the infrastructure around electricity and we know how to make robots, like if you can give a robot an ability to think, then now we're going to have this whole robotics and AI revolution that happens alongside of the thought revolution. Like, that's the thing that makes this much different than the internet. Like, the internet was purely this disembodied industrial revolution where everything was about these products that exist in cyberspace or in our thoughts on screens. And AI allows us to have another revolution that is of the magnitude of the type of change that we've undergone over the last 30 years with the internet, but bring that back into the real world again.
Yeah. Crazy times. Anything else? Going once? Going twice?
Thanks for having us on.
This is the Rebellionaire crew, by the way. I think we're all sponsored or work for Rebellion.
Yeah, that's right.
You work for me, Farzan. I should say that this isn't sponsored content too, by the way. This is just, we're just having a conversation. I don't think so.
Should
is
it be
it sponsored? Am I
I was planning
am
on
I ponying
sponsoring.
up? Okay, then this is sponsored content, but
okay, so anything bad I ever said about Matt in this episode is null and void. He's the nicest person I've ever met. Look at how beautiful he is. And what the hell was that?
I'm getting mulch delivered and something just happened.
I'm getting mulch delivered and something just happened.
I don't know. I heard a truck. Oh yeah, there's a big truck up in the air right now.
Okay.
That's what that was.
All right, well, we'll let Matt go and shovel the mulch and figure that out. Okay, ending recording. Go check out Rebellionaire. We'll do an ad as well, but if you made it to the end, rebellionaire.com/Farzad. Go check him out. Shout out Jordan. Shout out Matt. Shout out Hans. Let's go.